we're going to solve the basic percent problems, but we're going to do this in the context of some story problems. It's really done the same way, and we can do these with either the translation or proportion methods. So again, I'm going to show both methods, and I'll just start with translation method. So this story problem, this first example, says that 52% of English students on campus are female. If there are 8,000 English students, how many are female? So when you have a story problem, I think maybe the translation method can be a little bit harder because you kind of have to figure out the is and the of and the percent and all of those things, right? It's a little harder to look at this and figure out which part is my is and which part is my of, although you can still do it, right? And in terms of like proportion, that's a little easier to look at and figure out your is and your of and just put them in the right spots. But to actually translate it word for word is a little tougher. So if you're going to use the translation method, what I would say is a good idea to do is, can you summarize what it's asking you to find, right? Can you leave out all the details of the story problem? So leave out all the things about the campus and the English students and females, and just what is it wanting you to find, right? Is it wanting you to find the percent? Is it wanting you to find how many there are, or how many there is, in other words? Or is it wanting you to find like the total, how many it's out of, right? And in this case, I basically can say, well, I know the total, right? And I know the percent, so I must be trying to find the is part, right? So really what it's asking me here is it's asking me what is 52% of 8,000. And so that's really the tricky part using translation on story problems, is just being able to kind of summarize and rewrite your question, right? That's really what's going on here. I know that 52% of English students on campus are female. I know the total number of English students. So really I'm trying to find out how many are female, right? I'm trying to find the is part here. So what is 52% of 8,000? Once you do that, it's not bad, right? So this is going back to translation. Is translates as an equal sign. What translates as your variable? I'm just going to use X. So X equals, and then 52% of 8,000. So that would be 0.52. Of means multiply. So I'm going to multiply that by 8,000. And then I just go off to the side and do this. So 52 hundredths times 8,000. I'm really just going to do 52 hundredths times 8 and attach 3 extra zeros. So 8 times 2 is 16, regroup. 8 times 5 is 40, plus the 1 I regrouped would be 41. And then I need to move my decimal over 2 spaces. So this ends up being 4,160. And then since it's a story problem, make sure that you put the relevant units here. This is asking how many students are female. So this would be 4,160 female students. And then just check the reasonableness of that, right? So, I mean, we wouldn't expect to get something like 7,000, because 7,000 would be way more than 52%, right? 52% is close to half. So this number should be close to half, a little more than half, than 8,000. And then to show you what this looks like for the proportion method, so we could do, we know the percent is 52, so we could go ahead and put that over 100. And then the is part would be how many of these students were female, how many are, or what part is female, right? So that's the part I don't know. So we could use X, or if you want to use F for female, or whatever you want to use there. And then the of part, I do know the total, right? I know how many it's out of. It's out of 8,000. So then we would cross multiply. So 52 times 8,000 equals 100 times F. So 52 times 8,000 would be the same thing that we did here, except you wouldn't move the decimal over. So you would get 416,000. And then if you divide both sides by 100, it just knocks off 2 of the zeros, and so you get 4,160. All right, this last story problem has just a little bit more to it. So it says in a bag of 340 jelly beans, 80 are root beer. What percent of the jelly beans are not root beer? So looking at this, I already know that we're going to be finding a percent. So whatever method we decide to use. And there's a couple of approaches that you could take here. So really, when you add the translation method and the proportion method to the way that you could approach this whole thing where it's giving you the number that are root beer, but then it's asking for the percent that are not root beer, right? So when you add the different approaches that you could take with that, there are a lot of different ways that a student could approach this problem, right? So one way, for example, is I could just right from the start say, well, if I'm looking for the percent that are not root beer and they're telling me how many are, let me first figure out how many are not, right? So like the first thing I could do here is take 340 total jelly beans, subtract the 80 that are root beer, and figure out that that means there's exactly 260 jelly beans that are not root beer. And that's not my answer, but that's a number that I'm going to need, right? If I want to find the percent that are not root beer, then I'm starting with the number that are not root beer. So that would be one way to do this. And then we can use from there, we could use either of our two different methods. So if I were to use the translation method, I think that this would look something like, I'm going to summarize what it's asking, and it's really asking me what percent of, we know the total is 340, right? Is, and then my is part would be 260. And then translate that, right? Or if you're going to solve this with the proportion method, I guess I'll go ahead and write that. So I'd have something like P times 340 equals 260. So something like that is what it might look like. Or if I was going to use the proportion method, then I don't know the percent part. So that would go over 100. And then the is part would be 260. And then the of part would be the total. It's out of a total of 340 jelly beans. So that would be my initial setup for that problem. Just in the interest of time, since I've done this several times already, I'm not going to solve this with both methods. I'll just go ahead and I'll solve it with the proportion method. So cross multiply, this would be 340p equals, it's going to end up being 260 times 100. And then I would divide both sides by 340. So off to the side here where we got some room, 26,000 divided by 340. That's a fun one. So let's see. It's not going to go into 2 or 26 or 260. It will go into 2600. Well, 3 times 6, so 300 times 6 would be like 1800. So it should be a little more than that, maybe not much more. I'm going to try 7 and see how that works. 7 times 4 is 28. Sometimes 3 is 21 plus 2 is 23. Did I make it? Yes, that's 220 is my remainder there. And then bring down my 0. Since 7 times 340 was 2,380, this should be a little bit smaller than that. So yeah, this should be just 6 times. So 6 times 0 is 0, 6 times 4 is 24, 6 times 3 is 18, plus 2 is 20. So that gives me 160 as a remainder. I'm going to have to go ahead and insert my decimal and bring in a 0 and bring that down. I'm going to guess that this goes in, 300 times 5 would be 1,500. Yeah, I think that's a little too much though when you add that extra 40 on there. I'm going to try 4. It's either 4 or 5, I think. 4 times 0 is 0. 4 times 4 is 16. 4 times 3 is 12 plus 1 is 13. So that is giving me 240. Yeah, so made the right choice there. I'm going to go ahead, usually with percent problems, you don't necessarily want an accurate answer. You don't have to get all these digits. I'm going to do one more decimal, and if it doesn't work out on this step to have a zero remainder, then I'm just going to round it. So let's see, 340 would go into 2400. I think I already did that. I got 7 times 340 earlier was 2380. So I think that's what I'm going to use here. So 7 times 340 would be 2380. And I'm going to get a remainder of 20 there, but that's okay. I'm not going to worry about that. So I know that this number keeps going. It doesn't repeat as far as I can tell, but I'm just going to round it. Since I've only gone out to the hundredths place, if I'm going to round, I would round to the tenths place. So that 7's going to bump that up. So I'm going to say that this is about 76.5%. There's about 76.5% that are not root beer. All right, and I know we got our answer to that, but just to show you some other ways that you could have approached this, or a student might approach this, we decided when we did this that we were going to do that subtraction right at the beginning. You wouldn't necessarily have to do that. So you could maybe wait on that. So for example, instead of asking what percent of 340 is 260, we could have just said, well, let's not worry about the part that aren't root beer yet. Let's just find the part that are. So we could have translated this as what percent of 340 jelly beans is the root beer, is the 80, right? And so then you could translate that. And so that would be what percent would be P of means multiply. So multiply that by 340, and then that would equal 80, right? And then you could solve that. Or if you're going to do a proportion, you do it the same way. You do P over 100 equals 80 over 340. So you have some choices there, and then solve with either of those methods, right? So when you solve with those methods, just in the interest of time, I'm going to skip showing my division there. You're going to end up getting, it's going to round again. It's going to be like 23.5% roughly. It's like 23.52 and it keeps going, right? But technically, when we find that, that's not the answer. That's 23.5% that are root beer. So this is another way a student could approach it. It's just then instead of doing their subtraction at the beginning to find what's not root beer, you could do it at the end. So then if you know that 23.5% are root beer, then we could take 100% of the jelly beans and subtract the 23.5% that are root beer. And then that would give us 76.5%. I guess I should say that's approximate since it's rounded. Approximately 76.5% are not beer. So you have lots of choices here, lots of approaches that a student might take in terms of when they're going to do their subtraction, when they're going to do translation or proportion methods.